Okay guys, so in this video we're gonna do again the elevator problem. The only now difference will be the elevator speeds up at 2.50 meter per second square while moving downward. So again, it will speed up moving downward, and we need to find out now the apparent weight, or F of the scale. So how do we do this problem? So if it's moving downward and speed up, so let's do first conceptual setup in here. So we got speeding up, moving downwards, so velocity will increase downwards, something like this. So this is, let's say, V3, V2, V1, and I'm going to do the delta V, V final minus V initial. So this is the final here. This is V3. And then we're going to do now minus V initial, which is V2. So we're going to do now this way. So minus V2. And of course, now, of course, we can see now the resultant going this direction because this vector is bigger here. And that would be our delta V. So now this will give us the understanding of the direction of acceleration, which will be going downwards. And also this will give us a direction of the F net. That is important now to set up our diagram here. And so how is it going to look now, this diagram? So we know now this F sub net will be contributing to the greater force looking downwards. And so the F of the scale will be smaller vector. And so our setup will be looking very the same way as the previous problem. Now we can say that F net, part of this force right here, is equal to, this is positive direction. And again, because our F net is pointing to the negative Y, I'm going to put a negative in here. And then we're going to have the F scale positive because it's pointing to the positive direction, plus minus F sub G. And so all I have to do now is to find F scale. And F scale will be equal to F sub G minus F sub net. Okay, so we're ready to move now to solve this problem. F scale is equal to, now I'm gonna represent force. Here is a second law of Newton, which is M times G minus, remember guys, the A is going downwards, pointing to the negative direction. This is where I'm going to take care of this negative, doing this setup in here, when I put the negative positive in front of these forces here. So we took care of it. And we're going to factor out, again, the mass will be G minus A. And now we can plug in the values. That will be, now mass is 92 kilograms. And in parentheses here is going to be 9.80 meters per second square minus 2.50 meters per second square. Looks like we're going to wind up, guys, with the same answer as in the previous problem. So I'm going to now again use my now 9.8 significant figure rules to know that I have 3 significant figures because we're going by precision, 100th place. So in the 100th place, I have to report the 0 here. Again, my calculator doesn't know my significant figure rules. And all I have to do now, multiply this by 92. And I got the same answer, guys, as the previous problem, which will be 6.7 10 to the positive 2 newtons. We can also state this number as such. And that's how you solve the elevator problem when it's speeding up, moving downward.